to the Journey Shake Hand. Well, today's warm-up is extremely important. You need to try it as best you can, and notice that you're given PA, which is pascals. So how many pascals in a kilopascal? You figure that one out and use a conversion factor. And I'll be right back to review the answers with you. Number 1 had quite a challenging equation for you. You had to remember that peroxide was a polyatomic ion with a -2 charge, and therefore we need 2 sodiums to get the compound to 0. We have this 2-2 ratio in the peroxide compounds, and oftentimes. Now, because I only have 1 sodium here and I have 2 here, I'm going to go ahead and double this because that gives me 4 sodiums, and I know I have an odd number of oxygens here because I had 3 oxygens. And sometimes it's trial and error for you to get the correct coefficients. And then I need 2 waters, and then it is balanced. Now I'm given 10 grams of the sodium peroxide, and what I'm looking for is the amount, the volume of the oxygen for non-standard conditions. And therefore the first thing I will do is change my grams of sodium peroxide to moles. And 1 mole of sodium peroxide, I notice immediately that the unit that I'm given is grams, and therefore I must use my AMUs. And there are 2 sodiums, and each sodium is 23.0. There are 2 oxygens, and each oxygen is 16.0. And then I get 46 and 32, which gives me a total mass of 78.0 grams per mole for sodium peroxide. And therefore I have 78.0 grams of sodium peroxide. Once I get to moles of sodium peroxide, I can change using my mole ratio from the balanced equation. And there is 1 mole of oxygen for every 2 moles of sodium peroxide. And when I do the math here, I'm going to get 0.6410 moles of my oxygen. Once I have that, then I will put this into the ideal gas law, solving for volume at these non-standard conditions. And I know that PV equals nRT. And therefore, if I'm solving for volume, equals nRT over pressure. And therefore, I put in the value 0.06410 moles of my oxygen. And the ideal gas constant that I'm going to use is kilopascal. Even though I'm given my pressure in pascals, I will have to make a conversion there to get it into kilopascal. And that value is 8.31 kilopascal decimeters cubed per mole Kelvin. And the reason I'm using decimeters cubed is because I'm going to be changing to centimeters cubed. And then the temperature is 20 degrees Celsius plus 273, and that gives me 293 Kelvin. And I divide that whole thing by my pressure. And in the problem, oftentimes students say, well, is that an error that you have up there? No, it was not an error. I was given pascals. And I have 1 times 10 to the 5th pascal. And therefore, I need to change it to kilopascal. And I know there are 1,000 grams in a kilogram. There are 1,000 fish in a kilofish. And there are 1,000 something or others in a something or other. So I know that I must put 1 to 1,000, or 1 times 10 to the 3rd. And what this gives me then is 100 kilopascal. Now, when I do the math here, I am going to get 1.5607 decimeters cubed. And because the question is asking for centimeters cubed, I will again make a conversion, what I'm looking for in the top and what I want to cancel in the bottom. And there are 1,000 centimeters cubed and 1 decimeter cubed. And therefore my answer here is 1560.7. I look back to my original problem and I want 2 significant digits, and therefore it is 1,600 centimeters cubed is my final answer. And there were some conversion factors in that problem. Well, that's always good practice because tomorrow you have a quiz. And I like this problem. So do the best you can. And we're going to go on to number 2 in just a moment. In number 2, we are determining the number of atoms of krypton. Watch out, Superman! So anyway, what we have to do first is find moles, because the ideal gas law will not go directly from, or I should say to, atoms. I have to go to moles first. And the ideal gas law is PV equals nRT. And therefore, when I rearrange this equation to solve for moles, moles is equal to PV over RT. And I'm now going to substitute in the values that I have. Well, I was given 970 torr. And the volume that I have is 930 milliliters. And 930 milliliters must be changed to liters because of my ideal gas constant. And when I do this math, I get 0.93 liters. And because I have a unit of torr, then I must use my ideal gas constant for torr. And that would be 62.4 torr liters per mole Kelvin. And the temperature that I'm given is minus 32 degrees Celsius. And we must always change to Kelvin for gas laws. And this then is 241 Kelvin. Now, when I do the math here, I am going to get 0.05998 moles of krypton. And then using Avogadro's number is equal to 1 mole, I can get the number of atoms. And there are 6.02 times 10 to the 23rd atoms of krypton in 1 mole of krypton. And when I do the math for this, I'm going to get 3.6107 times 10 to the 22nd atoms. And I look back to my original problem for the number of significant digits that should be in my answer, and that would be 2. And therefore the 1 does not round the 6 up, and my final answer is 3.6 times 10 to the 22nd atoms of krypton. And that's how you do number 2. And there you have warm-up number 1 and number 2, ideal gas law. We're having some fun with that, aren't we? And I can't wait until the labs that we're doing the end of this week. Well, that was some fun, and thanks for being here, and we'll see you tomorrow.